Okay, we are recording. Okay, so the first exercise that we are going to see is it's continuation of a simple substitution cipher. Let's say that you have two keys, K1 and K2. Here we have an example for K1 and K2. And we know that there is a unique key K, such as if I encrypt a plain text with K2 first, then I encrypt the result with K1, it will be the same thing to encrypt just with the key K. So they ask you to find the key K. So do you have an idea how to do that? You should have an idea. So tell me. You have this key. So remember, what does it mean? That we go from the alphabet to the cipher, no? Just put cipher here and plain here. The plain will be the alphabet. Okay, I need the alphabet. Let me generate it better. So echo a dot z. I'm going to remove the space that will appear. So the first key means what? This is key 1. That we will change a A into a R, a B into a W, no? This is what the first key means. Okay, we have a second key. Just put that here. We have a second key. And the second key is this one. What will be just one key that do both? What will be K? So first we apply K2, no? First we apply K2, then K1. So look at A go to a X when I apply K2. Then a X, when I apply K1, go to a E. So A will go to a E. A B, when I apply K2, go to a H. Then a H go to a J. So a B will go to a J. Then a C go to a Y when I apply K2. And when I apply K1, a Y go to a N. So here we'll have an N. Let me do the last three one. A X go to a Z, and a Z go to a M. Y go to a R, and a R go to a D. And the last one, a Z go to a L, and a L go to a L. So that will be that, okay? That will be the key, big key that will do both of them. So a way to verify that using TR, the command TR will be how can I verify my finding here? I can do echo the alphabet. Copy the alphabet from here, or I can just generate it with the echo command. So first I apply K2. So I mean I'm going to transform the alphabet into which is 26 letters, into that. Then I apply K1. I'm going to transform the alphabet into this. So here is the result. So as you can see, we compute the first three letters, E, J, N, and we compute the last three letters, M, D, L. Okay, so it's very easy to answer a question like that. Okay, let's see what else. How many different keys are possible? What is the number of keys that we have with the simple substitution cipher? How many keys? Let me try to explain it. You should know that. So we have the alphabet. Okay, we have some letters. So 26 position. So you have to think. I have to put the A in some position. How many possibilities I have to when I put the A in the array of 26 position? 26 position. So to put the A, I have 26 possibilities. Once I put the A, let's say that I put the A here. So we have 26 to put the A. Now I come to put the B. How many positions are for the B? 25. So let's say that I put the B here. So up to now, just to put the A and the B, I have 26 by 25. Then I put the C. How many positions I will have for the C? 24. So blah, 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 up to what? When I come and put the Z, there is only one slot left. So time 1. What is that? Factorial of 26. So how many keys we have? Factorial of 26. So you can compute factorial of 26. It's a big number. So those are all different keys. So here we have factorial of 26 is this 4 times 10 to the 26. Look at the number of keys. So they ask you, do you think the simple substitution cipher is a safe algorithm? So you have to think, will somebody start a brute force attack knowing that we have that much keys? How long it will take in an even powerful computer if I try all the keys to try to find the correct key? When we did the Cesar cipher, we did have only 25 keys. But here we have a bunch of keys. So the question is there. Is it a secure encryption algorithm? Yes. Okay, so it is not, in fact. We have a lot of keys. If we cannot do a brute force attack, that's true. A brute force attack, don't think about a brute force attacks. Even if you use all the computer of the world, it will take you years. So there are other attacks that we can do over the simple substitution cipher. So let's answer this question first. If you use the simple substitution cipher and you encrypt Oxford, can you get this? Why?
Because Oxford has 2 O's and 2 letters.
Correct. Because a simple substitution cipher always, if I have a O, several times, it will be always mapped with the same letter. So here we can say O is mapped with P. Then we see that O is mapped with G. There is a contradiction. It cannot be Oxford. Okay, a simple letter is always mapped to the same letter. Okay, because you make a substitution. You say, I will substitute the A by F, for example. I will substitute the B by G. So all the time you substitute B by G. So there is no way that this have been Oxford. Okay, the ciphertext blah 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 was obtained by encrypting the quick brown fox jumps over the gate using the simple substitution cipher. How much of the key is determined in this plain text ciphertext? So this always happens, that you at one point you get a pair of ciphertext and plain text. And this gives you a lot of information when you have a pair of ciphertext and plain text. So here they give us a pair. We know that this ciphertext was the encryption of this plain text. So they tell you with this information how much of the key you can get. So let's try to do it. So I'm going to put in a file. Let me remove this. So what we have as plain text is this. And the cipher is this one that I'm going to copy. And we are trying to discover information about the key. So the cipher was this one. Okay, so what can you determine? I want you to tell me what do you know about the key.
Have all the letters, but you got the vast majority of them.
Yeah, so how can we determine the key? Here we want to determine the key.
Look at all the vowels first.
So what can we say? For example, a T will map in a M. So we can say here, a T will map into a M. Then we have here a H map into a B. So we know that a H will be a B. Then we know that a E will be a R. Okay, the E here will be a R. So I put here a R. Then we have a Q into a O. So Q into a O. Then we have a U into a J. So here J. Then we have an I into a F. Please, if I do a mistake, let me know. Okay, so we don't have to repeat the exercise. A C into a G. A K into a and a B into a S. Then we have a R into a W. And we have a O into a N. And we have a W into a T. And we have a N into a E. And we have a F into a C. And a O into a N. Okay, we already have the O into a N, so it's a confirmation. A X into a K. And we have a J into a Q. J into a Q. Then we have a U into a J. There already. Then we have a M into a D. And we have a P into a I. and we have a S into a L, and we have a O into a N, it is there, then a V into a U, V into a U, then we have a E into a R, E into a R is already there, a R into a W, a R into W is already there, a T into a M, T into a M is there, H into a B is already there, a E into a R is already there, a G into a X, a G into a X, A into a H, we have a T into a M, which is already there, and finally we have an E into a R, which is already there. So look, we know a lot about the key, no? We know 24 letters about, we know 22, sorry, about 24. So the ones that are missing here, as you can see, we don't know what will be the D, we don't know what will be the L, we don't know what will be the Y, and we don't know what will be the Z. And here also, we can determine the missing letter. So let's do some commands to verify that the missing letter are this one. So what can I do to show that the missing letter are D, L, Y, Z into the plain text here? What do you recommend? I can work on this message. So first, I need to suppress the spaces. So how do we suppress the spaces? We pipe, for example, with TR-D, like that. We suppress the spaces. So as you can see, the quick brown fox jump over the gate is there. Then, to sort them, we need one letter per line. So we can tell, we've said that we want to sort them. So substitute. So here, substitute what? So I need to define a pattern, and this pattern is a capital letter. I'm going to put the capital letter on a new space. This pattern is pattern 1. So here I say, substitute it with pattern 1 on a new line. Okay, we have a enter at the end. I'm going to tell this echo, the first echo, do not send an enter. Okay, so we have all the quick brown fox jump over the gate. So I'm going to sort them. As you can see, for example, we have 4E. Let's verify that. 1E, because they are sorted. 1E, 2E, 3E, 4E. Good. So this is good. If you look, for example, they say there is 2H. So there is a dir here that have a H, and there is another dir. For example, there is 3O. Let's verify that there is 3O in brown, in fox, and in over. Okay, so now when they are sorted, when I have 3O, I just want to put just one O. So there is a command that is called unique. Unique, when there are several lines that are the same one, we'll just keep one. So as you can see, now I don't have 3O, I don't have 4E, I just have 1E. But they are vertical. I want them horizontal again. So what I can do, I can say delete the new line. So they will be horizontal. So those are all the letters. And since the prompt come at the end, I can say at the end put a new line. So I can do that. Semicolon echo. So those are. So this should be exactly Okay, if we look here, we should have a missing D. So look at C, E. We have a missing D. We should have a missing L. K, M. We have a missing L. We should have a missing Y. We can see it, and missing Z. But instead of me working, I can ask the computer, tell me the missing letters. So how do I do that? I can, for example, generate the alphabet. Please generate the alphabet. And I can tell it, delete from the alphabet this letter that are the ones that are present. And show me the missing letter. The missing letter are D, L, Y, Z. So I did not have to think about it. Of course, I can do one command that will do everything for me. So what I can do also is, for example, you see this big command that generates everything for me? I can just put it at the end there. I'm going to put it like that, okay, to say it's one command. Oh, I have to see tr minus d. Okay, here it is the result. So with one command, I show what are the missing. For example, in the ciphertext, we can see what letters are missing. There will be 4 letters that are missing, of course, no? So let me see what are the letters that are missing in the ciphertext. So I don't have the computer compute them for me. I don't have to think. The ones that are missing in the ciphertext are those ones. Let's write them. So if you look, there is no P here, there is no V, there is no Y, there is no Z. You see, I ask the computer to do it for me, I don't do it by myself. Okay, because I'm going to make a mistake if I do it by myself, I'm sure. Okay, so let's see more about the exercise. How much of the key is determined? Of the 26 letters, we know 22. Develop a program that will show the same information. Okay, so they are asking you to develop a program that will give you that. That will say A is mapping to H, B is mapping to S. Okay, let's skip this exercise, but you should be able to develop a program that tells us at the end, A is mapping to B, H, B is mapping to S, C is mapping to G, E is mapping to R. It has to skip, of course, the D. It has to skip the L. It has to skip the Y and the Z, okay? So how many different possible keys could have been used to encrypt the plain text? So if we already know this information, how many keys are possible?
Is it 4 factorial?
Yeah, 4 factorial. Because when you want to put the P, you can put the P here, 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 or here. So when you put the P, you have 4 positions. Once you put the P, there are 3 positions left. So when you come to put the V, there are 3 positions for the V. When you have to put the P and the V, you have 2 positions left. So when you put the Y, you have 2 possibilities. When you have put the P, the V, and the Y, the Z just have 1 possibility. So it will be 4 times 3 times 2 times 1. So it will be 4 times 3 is 12, 12 times 2 is 24. So there are 24 different keys. Okay, they say write a program that generates all those keys. Let's do it. It's shorter, a program. I want to do a program that shows me all the keys. Okay, help me with that. What should I do? Let's do a program in Python. Let's call it generate all keys. Why? Let me touch it first. to create it empty. Let me change my write on it so I can execute it. User plus execute. Okay, let's edit it now. I'm going with the hash bang. I'm going to say that I'm using Python. So Python 3, of course. Okay, so that will be four nested for loop, isn't it? Do you agree with that? So what can we do? So we can do for, let's put SHA-1. Or let's call it, yeah, for SHA-1 in. So what are the possibilities for SHA-1? We know that the missing are P, V, Y, Z. So it's SHA-1 can be P. I can just write like that. P, V, Y, Z. What else? What should I do after that? Huh? Do you have an idea how to proceed with this? So we will put, for example, if char1 here, sorry, if char1 is not equal to char2, we go a little more deeper. 1, 2, 3. We go with char3. Here we put if char1 is not char3 and char2 is not char3, we will have another for loop. With char4, and here we'll have another if. It will be what? If char1 is not char4 and char2 is not char4 and char3 is not char4. So we are going to show the key. We are going to show one of the key. So print, and let's show one of the key. So we know what about the key? That it is like that. So let me just put here. So here we need a character, and this character will be char1. Here we need a character. This character will be char2. And at the end, we need two characters. There will be char3 and char3 and char4, no? Char3 plus char4. Do you realize that I try to avoid repetition. I don't want 2 times P in the result, no? So I think this, let me see if chair 1, chair 2, chair 1 is, yeah. So let's execute that. Where I am, I saved that where, let me see, it is there. So generate, let's see if we have 24. So how do I know if I have 24? I don't want to count them. I can say word count dash line 24, as you can see. Okay? Number line. Look how it's powerful. First solution to solution 24. So let's see. All of them have to start with HSG. So look at the first 6 lines have a P here. Then the other 6 lines have a V here. Remember, it's P, V, Y, Z. Then the other 6 lines have a Y here. Then the other 6 lines, the last 6 lines, have a Z. If I look at the first 6 lines, this is what you know. If I put here P, I have to put the other that are left. For example, we are going to put it between A and D. Look at between A and D here. I put VV, YY, ZZ. And here, if I put VV, the last 2 one I YZ, ZY. You see that? Of course, so it's all the permutation that I can do. So those are the 24 keys that are possible. Small program, generate the 24 keys. I don't have to think. The computer do it for me. Very small program, as you can see. Okay, so let's continue. Okay, so write a program that generates all those keys. Okay, decrypt the ciphertext, which is known to have been encrypted with the same key as the above example. So we have this ciphertext. It was encrypted with the same key that we use for this. So what do we know? Let me put the ciphertext here. Let me see if it's the same one between the V and the C. Yeah, there is it's another word. So this is a ciphertext. Tell me how to decrypt it. Information. We did find already this. So we know that the alphabet, let me put the whole alphabet, will be translated this way, but I don't know all the letters, but I know 22 of them. So what do you think we can do here? You see here we have star star, which means that we don't know Y and Z what they will be. So let me suppress Y and Z. Y and Z, I suppress them, and I suppress the star star. Here the 4th letter is a star, so we don't know what will be a D. So let me suppress the D here, and this. Then what is left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We don't know what will be the L. So look, you see the L will be one of these 4. We don't know. So let me suppress the L and suppress the star. So this is perfect. We have the 22 letters that we know of the plain text, and we know how they will be changed. So the thing that in the ciphertext, we have PVYZ, and those PVYZ, for example, this Z, I don't know what it will be. This P, I don't know what it will be. This Y, I don't know what it will be. So before I apply that, maybe I will put another TR that will say that I don't know how to translate PVYZ. So let me put PVYZ. I'm going to tell it, translate it with star, 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 star. So look at the translation that I have. I need to decrypt, no? So I didn't put them in the correct order. Sorry for that. I need to decrypt, that will be encrypt. So look at, I'm telling this P that I don't know what it is, please transform it in a star. So for example, as you see, we have a P here, it's a pure star here. This Y, I don't know what it will be, so transform it as a star. So we have a star here. This Z, I don't know what it will be, so transform it as a star, we have a star here. So this, here we have a V, it's appear as a star. And here we have a P, it's appear as a star. So the one that I don't know, but all the other one I'm sure. So look at what we have. The something ran, something from, something, something. Can we already guess what was the original text? We have a lot of information, no? What do you think? What should be this word? Of course. So if it is whistle, what does it mean? Look, for example, here in the ciphertext we have a P, which means that the P, the L have to be transformed into a P. So I did not have this information, so I'm going to add it. So let me put it, and I'm going to tell in the ciphertext a P should be transformed into a L. The ciphertext a P. Oh, remember that now I have to say, don't change the P to a star because I know already what is a P. So look at, we have whistle here. Oh, what should be that? Very easy. London, of course. So if I have to be a London, which means the letter Y have to be transformed to a D. So I'm going to say the letter Y in the ciphertext is a D. And I'm going to say here, don't change the Y in the star anymore. Just the V and the Z. So look at the whistle run. That have to be away from London Zoo. So this, the whistle run away. So the V have to be a Y. So let me say, the V in the ciphertext have to be a Y in the plain text. And don't transform the V in a star anymore. So we have the whistle run away from London, and the Z have to be a Z. So the Z in the ciphertext have to be a Z in the plain text. And let me remove this translate. Okay. Now we have the key. The original key was this one. So just because we get a pair of plain text ciphertext, we were able to infer the key. So you see how it's dangerous? So it's not that strong as we will think, because of course we have a lot of keys. We have factorial 26 keys, which is a big number. But look at what we can do if we get a pair. Okay, you can say me, how do you get the pair? It's not easy to get the pair. That's true. But sometimes you capture the enemy. And the enemy will talk because you are going to torture the enemy, of course, to make the enemy talk. And sometimes it's, if you look, the Second World War, the Germans have made a machine to encrypt. It was called Enigma. And a very brilliant scientific break the machine, the Enigma machine. And he have information. He knew that the German will always start a message with Hi Hitler. So you knew that the first beginning of the message will always be Hi Hitler. That was information for him. With this information, he already have information about the message, the encrypted message. So with that, he was able to break Enigma. And that and other inference that he did. So that was a mistake from the German to always start a message with Hi Hitler, because the ally at one point knew that any message that will transmit will start with Hi Hitler. So they took advantage on it, no? So all this information that you know on your enemy, you finish to exploit it and finish to crack what they are doing, no? Let's see what else we have. So we were able to decrypt this totally. Okay, so we already saw that. Okay, so at the end, the simple substitution cipher is very unsafe. Why? Because every language have characteristics, and you can take advantage of the characteristic of the language. So let me show you, for example, English, the English language. Those are statistics of the frequency of the letter in English. The most common letter is E, and it appears like 30% of the letter. When you take a text, 30% of the letter are E. Then the second most frequent is a T. So if you look here, we have the spectrum where the more frequent letter is a E, then a T, then an A in English. And the least frequent letter is a Z. This gives you a lot of information. Of course, in Spanish, the most frequent letter is not the E, it's the A. So according to the language that speak, the people that they need to crack the message, they will use information about the language. And we know about all the language. So for example, look at things that we know about English. Frequent one-word letter, I. Frequent two-word letter, of, to, in, it, is, they are here. Frequent three-word letter, the, on, for, are, but, those are very frequent in English. Most common double letter, SS, EE, OO, ML, LL, those are. These give you information when you see the ciphertext. So you can exploit it. So look. Here, we are going to see that was encrypted using the simple substitution cipher. And we are going to decrypt it. Even if you don't know the key, even we know that there are factorial 26 keys, possible keys. We are not going to make a brute force attack. We are going to take advantage of what we know about English. So let me take this text and we are going to try to break it. So let me put it in a file. We call this file cipher. I'm going to paste it there. Yeah. Coming from a PDF doesn't make it easy. I think it is okay now. So this is the text. I hope there is no your OQ. Okay, this is the text. This is the ciphertext. So they already count. You should do a program that counts each letter. So in this text, they already saw that G appeared 35 times. So G is the most frequent. So what can you say? It's probably E, correct. So the second more frequent is O. It will be probably what? T, because the second more frequent letter in English is T. So let's try to take advantage of that and see what happens. So I am going to say translate, for example, a G into a E. Look, to make it easier, we are going to put the ciphertext in uppercase and the clear text, the plain text, in lowercase. So I say G into a lowercase e. Okay? And all the other letters, I want to keep them as star for now. So I will say translate all the other capital letter into stars. So I need to write 26 stars. There is a way to write 26 stars. Is the character star, I want it 26 times. So if the G is an E, this is what we have. Then we can add other information. We think that the O will be a T. So let's put a O will be a T, a lowercase t. So look, word of 3 letters that start with T and end with E, probably the. So this gives information that the letter that is here might be a H. You see how I can take advantage of that? What do you think? What can we do? We try this? So if this is H, look at the ciphertext, which means what? Where is the ciphertext? Let me show the ciphertext. The ciphertext is this one. So if this is D, L will be a H, isn't it? A L here, because we have a word of 2 letters and a word of 3 letters. This is the D. I suppose this is a D. So I'm going to say a L is a H and see what happens. A L will be a H. Look at what I have. Why do you think that will be this? There, these. This can be that. You see how easy it is? This can be what? They, them. Okay? So as you can see, very, very easy to find information. Okay. I will say that maybe we try this in a T something. So in English we have TA, we don't have word TA. TI, no. TU, no. TO, yes. Tu, we do have two. And TE, we don't have it. So it have to be a O. So let's try it. A Q will be a O. So let me put this information here. A Q will be a O. Let's see what happens. Okay, so yeah. So we have 2 the here. What do you think? For example, we can try here them. If we see that we arrive to a contradiction, we have to come back and try another possibility. I will say that this will be a then. If it's a then, the F will be a M. So let's try that. A F will be a M. So we have a them here, we have a, oh, this will be themselves, isn't it? THEM, something E, something, something ES. So this will be themselves, definitely. Okay, so let's try. So this themselves is where, so we are going to complete with this themselves. So these themselves should be this guy. So for example, the last letter is a S. So a N will be a S. So let me put that here. A N will be a S. We have more on themselves. And let's see if we, okay, let's continue. I think this is that, but let's continue. So them, so what is coming here is a L. So the L, THEMSE, so a V will be a L. So let me say a V in the ciphertext will be a L. Okay. Look at the let. Very common. So let's continue. So here, which is a R will be what? A R here will be what? A V, of course. So a R will be a V. So look at what we got. We got the themselves here. I think this is also, for example. This is however. You see? Very. Okay, let's do, for example, this also. So if it's also, however, something of two letters also. So a E will be a A. So let's try that. A E will be a A. And see if we don't have any contradiction. We have a also that we just did. Okay. No, what? Please. Yeah, that should be a please. So if it is a please, the X is a P. So let's put the X is a P to see. Please let us, or let something with let us, let us. Let us is impossible. I think it's us. Or let us know, maybe, no? So what do you think is this? Good, welcome. I think it's welcome also. So a U will be a W. So a U is a W. Okay, then W-E-L. A P will be a C. A P will be a C. So welcome to the course. Yeah, you're right. Welcome to the course, which means that a C and W will be UR. Let me put both of them. W will be, we have already C, UR. So welcome to the course. There are, this will be problem, of course. So, that will be what? Student. So there is a word, another word of two, another of three. So this is student. So STU. So the B will be a D. The B will be a D. So now we have a little more of student. So D, E, O will be an N. Oh, we already have O here.
B will be an N.
It's a B, that's it.
D.
D. So I make a mistake. S, T, U, D, E, N. So a D will be an N, you're right. D, N. Welcome to the course. One aim is for the student to learn about information security. This means hard work. However, we also want them to enjoy, no? I think it's enjoying themselves. So we can complete a little more. So one aim, I think this is aim. So Z will be an I. Let's put Z is I to see what we get. One aim is, so this is will be 4. One aim is 4. So a S will be a F. S will be a F. So one aim is for the student to learn about. One aim is for the student to learn about. This is about. So H will be a B. Be a B. H will be a B. So about information security. So a J will be a Y. Where I am. A J will be a Y. About information security. This means hard work. This means hard work. So a Y will be a K. The K in the clear text. A Y here. So this means hard work. However, we also want them to enjoy themselves. So, however, we also want them to enjoy. So M will be a J, no? M be a J to enjoy themselves. The course and the lecture should be fun. Please let us know if there are any problems so that we can attempt to correct them. So you see, we discover the key. I don't know if we discover all the letters, we can count. So if I want to know how many letters I discover out of 26, I can do that. I can do, for example, echo -n, so there is no, go to the next line, word count. So there are 22. I already discovered 22 out of 26. So which means that there are some letters that I don't know, but I already know a lot, as you can see. If the text is longer, I will have all of them. If the enemy keep using the same key, I know the key because I already discovered it. It's why you need to change the key frequently because the enemy got your key, and if you don't change it, of course, the enemy is intelligent. He don't want you to know that he know your key. Okay? Look, crack the following message. So we have a message here that was encrypted, no? Notice that the message is short. So the knowledge of letter frequency might not be very useful. So also use a dictionary. Okay. So as you can see, of course, if the text is very short, the frequency of the letter might does not work. For example, if the text is good, the most frequent letter is E, and there is no E in good. The second most frequent is T, and there is no T in good. So if the text is long enough, you can apply it. But on a short text, it's not a good idea to apply it. So they say use a dictionary also. So what we are going to do is to install a dictionary in our machine, English dictionary. So let me install it. They'll give you the step here to install it. So first I'm going to be administrative user. Internet 2 is my password as Eric. And I'm going to install a tool that is called aspell. Spell for spelling. And I'm going to install the English dictionary. I can install the French dictionary, Spanish dictionary, Italian. But since we are going to hack message in English, I'm going to install the English dictionary. Spell English is not there. Oh, I think, yeah. Oh, it's already installed. Okay. So this is already installed. Then you can have help. If you want to see the dictionary that you already installed, the list of dictionary that you have installed, you can use this command. I'm going to put it here. Let me replace, because it looks like it replaced it. Okay. So we have the English US, the English Great Britain, the English Canada, the English Australia. Okay, we have the English dictionary installed. Fine. So how do we use aspell? So let me create a file to show you. And we are going to make some mistake just to see that aspell will tell us where are the mistakes. So let's put we are in class. Let's put today like that. I hope it doesn't exist. To learn about, let's put about like that, about cybersecurity. I hope, let me put like that. Well, let me put double P, it doesn't exist, that you like it. Okay, we have a text. So according to me, I don't think this word exists. About does not exist like that, and op does not exist like that. Okay, so the way that you use aspell is aspell -- check. So look, it tells me, as you can see, we are in class, no problem. Today, those are the possible suggestions. So suggestion number 1 is the one that I want. I'm going to press 1 and it will replace it. About all the suggestions, I can ignore them, as you can see. If I want the first suggestion to get the correct about, I just press 1. Okay, cybersecurity doesn't have it, so I can add it to the dictionary. So I'm going to press A for add it to the dictionary. I hope the suggestion that I need is number 5. So I'm going to press 5. Okay, so now I have 2 files. I have a backup file and the original file, no? So the backup file is the one that have the problem, and the one that was correct is easier. So if I look at file.txt, we don't have the problem with today, we don't have the problem with about, and we don't have the problem with op. And the backup do still have the problem. Okay, another way to use it is with option, for example, list. If you want a list of the words that have problems, you can do aspell -- list, and it will show you a list. So it says there are 3 words that have problem. So it didn't find cybersecurity anymore because I added to the dictionary. I tell him cybersecurity is a word that should be in the dictionary. It was not in your dictionary. Please add it. So it is fine about, hope, and today, as you can see. Okay. So I'm going to generate with this command a list of all the words that are in this dictionary. So let me work as a normal user. I was an admin, still there. So aspell, let me change this dash because it was English dump master spell DL expand word. Okay, let me change that. Okay, let me see what we have in Word. Okay, we have all the words of the English dictionary, as you can see. I can check how many words we have. word count dash line. We have 126,657 words of English in this dictionary. Okay, so we need to break this. But they say they already warned me, they already told me, don't think that the E will be the most frequent letter. So they say the most frequent letter is a C in the ciphertext. So let me change my ciphertext. We have a new ciphertext. So you can see that we can exploit many things. We can exploit okay, I put the ciphertext here. So look, let's say that I'm going to say, okay, the most frequent letter here, they already confirm me, is C, which appears 7 times. So let's say I'm going to say C, I want it is as the most frequent letter, which is E in English, no? And the other letter, translate the alphabet with stars. So I need 26 stars. I'm going to put this time plus 26 times. Okay. So look, do we have a word in English that have an E and something after it? So I can ask the dictionary, show me all the words that have an E and one letter. So those are words with 2 letters. So look what I can say. Grep is very powerful. And with grep, I can say select the line that are this characteristic. So this is to say beginning of the line. This is to say end of the line. So you will have an E and you will have any other character. So it's a line that have just E and another character. So remember, the caret is beginning of the line, the dollar is end of the line. So look at, those are what we have in English that have E at the beginning and a letter. So it's kind of doesn't match, you know? For example, I don't know all these words. Do you know them? Okay, so we can try another one. We can try, let's say that the C is the second most frequent. I try the most frequent in this text, I try a E. It doesn't look like something viable. So now I take the second most frequent, which is a T. So I say the C should be a T. Okay, it's look much better because I will say that this is a 2. So of course I can ask the dictionary, show me all the words that are 2 letters and start with a T. So TH, TA, TE, TI, 2 is okay. 2, TI, TB, to all this. The only possible for me is TO. I don't know if you do agree. So if this is a O, I can say the G have to be a O. So let me put this information. The G have to be a O. What do you think? So I'm going to ask all the words that have 3 letters. Maybe it's better to do a star, no? A star is more visible than a plus sign. Let me do a star. This is a word of 3 letters that end with OT. So I can ask the dictionary, show me all the words of 2 letters that have a letter that have an O and a T. So it can be bot, hot, got, jot. What do you think? We can try, for example, what do you think? Which one do you want to try? We can try one if it doesn't give good result, we try another one. Which one you want to try? Which one? God? God is got, G-O-T. Okay, so if it's got, this means that the D is a G. Okay? Let's put here the D is a G. So look, let's see if here, let's see if we have a word in English that corresponds to this pattern. So I'm going to search in the dictionary. There is a letter, another letter, another letter, another letter, a T, another letter, a O, and a G. There is no word like that. So it's not got. So I can go back. I know that it was these three letters. Let me do it again. This three letter is not got. So let me show you again all the three letters that are possible. What do you think? What can we try now? You can try not. Let's try not. So if it's not, the D will be an N. So let me put here, the D will be an N. So we have not here, and we have more information here. Is there a word that corresponds to that? Let's try in the dictionary. So we will say, there is a character, another character, another character, another character, a T, another character, a O, a N. Wow, there are a lot, apparently. So yeah, it's probable, no? Look at all we have. So yeah, I will think we are on the good path. So what do you think? We know that this is probably a de. Remember, the de is very frequent in English. So let's say that this is a de to see what happens. So if this is a de, the HN have to be TH. Okay? So I'm going to say the HN have to be, it was HE?
It's HN, but it has to be
HN
will end up being HE.
HN have to be are we let me see. This is correct? Yeah. So HN have to be HE, isn't it? So it will be like that. What do you think? A word of two letters that have an E at the end. It should be B. So I can put the J have to be a E. A J have to be a B. What did I put here? A J, B.
Solve the puzzle.
What it is?
To be or not to be, that is the question.
Yeah, that's correct. To be or not to be, that is the question. So you see, for example, this can be this. No, it can be that. I don't know if there is other option for that. But look at, if I use a dictionary, I can say I have a word that have a T, a H, something that I don't know, and a T. There is only that in the dictionary. So I know that this is a that. So if this is a that, the F have to be an A. So I put this information, F have to be an A. I'll have a little more information, no? So O, ON, what else? OF, OR. We have more option here, no? But here, maybe we can look what we have. For example, here we have a word that have a letter, a E, a letter, a T, a letter, a O, a N. Of course, question is there because this is the solution, no? We can try all of them and you will get something that say it's not the correct one if you don't choose the correct one. So you see how we can crack the simple substitution cipher, knowing about the English, having a dictionary, knowing about frequent letter of English, frequent words. So it's why at the end, even if it's very difficult to break with a brute force attack, never use that. The only way that you can use that you remove the space. People do that. If you remove the space, it's much more difficult because you don't know the length of the words because you remove the spaces. So it's much more difficult. And people do that. They remove the spaces to use it. Okay. The visionnaire cipher. So let's see how it's works. So here it says that one of the main problems of the previous cipher, which is the simple substitution cipher, is that it is vulnerable to frequency analysis. I know that the E is the most frequent letter of an English text. Then the T is the second most frequent. So I count them and then I can try to have information about the text. So the visionnaire cipher is a little different. It's used this table as we will see. So look at this table. We have 26 row, 26 column. So in the first row, we have the alphabet from A to Z. In the second row, we have the alphabet from A to Z, but we make a shift. So we have A here, B, C, D up to Z. In the third row, we have A, B here, and we continue here, C, D up to Z. Blah, 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 up to, let me do the next row to the last. So we have A, B, C up to X here, Y, Z here. And in the last row, we have A up to Y, and the Z is here. It's just a shift of the previous row, as you can see. So how we will use it? So look what we will do. Let's say that we want to encrypt the plain text better later than ever. We need a keyword. So let's say that the keyword is today. So with the keyword, we are going to repeat the keyword several times. Today, 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 as many times as we need it. So we write the plain text, better late than never. Then we write today as many times as we need. And we are going to call that the key stream. So look at today. So the T with the B, the O with the E, the Y with the E. Then again today. Then again today. Then to da. Okay, we didn't need a Y because we end up with the plain text. So the key stream will give me a row. And the plain text will give me a column. So the intersection with the row and the column will give me the ciphertext. So remember, the key string gives me the row, and the plain text is in the column. So for example, the ciphertext of B will be U. How do I know that? I look at on the table, I look for row T, column B. So let's go back. Row T is there, and column B okay, row T, Column B give me a U. So I put a U here. Row O, column E should give me a S. Let's go back. Row O is there. Column T is there. It was OT. It was that. So it gave me a H. No, it was OE. So O, oh yeah, I asked you your help. OE give me a S. So the second letter is a S. Let's compute the third letter. D with T. So row D with T. So row D is here. And the T is here. So the intersection give me a W. So the next one should be a W, okay? So here we can see it, for example, D and T give me a W. So A and T should give me a T. So let's see, A and T give me a T, correct. Y and E should give me a C. So Y, row Y, and E give me a C. You see it? So you understood how we do, no? So in the key stream, we have the identification of the row, and in the plain text, we have the identification of the column, and we take the intersection for the ciphertext. So look at, for example, better late than never. If we use the keyword today, will be that. If we use the keyword Jacksonville, look, we first repeat Jacksonville, Jackson. And we do the same thing. If we use the keyword big, 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 B. Okay, we repeat the key, so we create a key stream. And let's see, for example, this C. So it will be intersection of row B with column B. Row B with column B give me a C. So the ciphertext is C. Here, this M will be the intersection of row I with column E. So row I with column E give me a M. So this is a M. So look at the exercise that we have. This is a ciphertext. It was encrypted with hello. What was the plain text? Let's do that. So let me copy the ciphertext. So you should be able to do it because you already know how to proceed. Okay, so we have a ciphertext. And the ciphertext is this one. And we know that the key was hello. So here I'm going to put the key stream. Key stream. Hello. 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 Hello with H. Okay. So I want the plain text. Let me put the table and I wait for the first letter. I need you to tell me what will be the first letter. Yeah, here we can see everything. What was the first letter of the plain text?
T.
So how do you get this T?
I kind of took a guess. I looked at H.
Yeah.
And the okay, never mind. Yeah.
So that's true. We know that the key stream give me the row. So I go and look at row H. So row H is here. And in row H, I have to look for a K. So here I look for a K. Remember, this is the ciphertext that we find in the intersection. So of course, the D, which is the plaintext, identified the column. So that was a D. See, we do the inverse operation. If you want to see it like that, the intersection between row H and column D should give you K. Let's verify it. Row H and column D give me K. Let's do the second letter. So I'm going to go to row E, and I'm going to search for I. The I is here. This is the ciphertext, so the plaintext is E. Let's do the third letter. I'm going to go on row L. Row L and search for an N. It is there. So it was a C. Then I'm going to go on row L again and search for a C. Row L, search for a C. The clear text is an R. Then row O, search for M. Row O, search for M. The clear text is a Y. Then row H, search for a W. Row H, search for a W. The clear text is a P. Row E, search for a X. Row E, search for X. The clear text is a T. Decrypt. And you keep going, and you will have the message. For example, you have another ciphertext here. It was encrypted with crisps, and they ask you to decrypt it. Okay, so the explanation is there. So I'm going to skip the explanation because we already explained how it's works. Okay, look at this exercise with the visionary cipher. A certain message is encoded with a 2-letter key. So you know that the key was 2-letter only, where all space were removed. You know, when you keep the space in your ciphertext, you give too much information. So people normally remove the space. So the encrypted message is this. So there are several words here. We don't know where is the space. We also happen to know that the second letter of the plaintext is an I. Break the cipher and find the plaintext. So if I start doing this exercise, they say what? Okay, so let me remove this. We know that the cipher is this one. Okay, so they say that the key is 2 characters. We also happen to know that the second letter in the plaintext is an I. So in the plaintext, the second letter is an I. So we don't know this one. We don't know all this one, okay? So we know that the key is 2-letter long. So we can determine this one, isn't it? We can determine this one. Because we have the plaintext and we have the ciphertext. So if I ask you determine this one, let me put you the table. Here is the table. Because we know that the second clear text is a plaintext is an I. So how do I determine this one? So if I have the plaintext, I know that I'm in column I. And in column I will search for a W. So I go to column I, which is the plaintext. Remember that plaintext is the column. I search for a W. And the line, which is O, will be the key stream, isn't it? So you know that is 2 letters long. So what do you know? What do you know? That also here you have an O. 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 So you don't. And there is another letter. It can be, for example, P. So it will be PO, 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 because it's 2 letters long. It can be J. We can do a program because there is only 26 possibility. And look at all of them and see which one makes sense to us, because these have to be English text, no? So what do you think? How can we continue from here? Look at, now we have the OW, so we can know which one is this one. Let's determine this one. So row O, we will search for a W. Row O, we search for a W, it gives you an I. So here we have an I, isn't it? Then row O, we have an H. Row O, we have an H. This gives me a T. So here we have a T. Row O, we have a S. Row O, we have a S. This gives me a E. Row O, we have a B. Row O, we have a B. This gives me an N. Row O, we have a K. Row O, we have a K, give me a W. On row O, we have a F. Row O, we have a F, give me a T. Row O, we have a F, it's giving me a R, sorry. Did I make any mistake? I think it's correct, no? Okay, so we already have this information. So look, we don't know where are the spaces. We need to be my interpretation of this. Can we have a word just in R? No, there is no word in R in English. So can we have a word with 2 letters ending with R? Yeah, so we can ask the dictionary to show us all the possibilities. So let's see that. So who I am here? What happened with the keyboard? It doesn't work. Oh my God. Oh, finally. So we want to see all the words that end with R and that are 2 characters long. So some character on the R in our list. So those are the possibilities. What do you think? Do you think we have or at the end of a sentence? I don't think so. We will have or at the end of the sentence. So I don't think it's 2 words. we can say, okay, if it's a two words, let's try to see what will happen. We can arrive to a contradiction. So if it's a two word on the sentence end with or, what will be the consequence? Let's say that the sentence end with or. So we have an O here. What does it mean? We need to find a contradiction, something that say it cannot be or. So if you have an or here, what can you say? What was the letter here? So look at, I need to go to column O and search for N. Column O and search for N. Column O and search for the N. Where is the N in column O? It is there. So it will be a Z, isn't it? Which means that this will be a Z. If this is a Z, this is also a Z. This is also a Z, this is also a Z, this is also a Z, this is also a Z. Let's see, so the word was zo, 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 okay? Let's see if we arrive to a contradiction. So, Z, let's be sure that I didn't make any mistake, no, because I don't want to repeat it again. So let's check that. The O, no, Z intersection O should be N. So Z intersection O, yeah, should be N. So it's correct. So let me put the plain text here. Oh. I need a ciphertext that is B, and I'm going to go over row Z. So Z intersection with column will give me a B. It's a C. So here we'll have a C. Do you agree? Let's continue. Z intersection a column should give me a W. No, Z intersection a column should give me a G. So Z give me a G is H. So it starts with CIHI. Z intersection something should give me a B. Something have to be a C, no? Z intersection something should give me a B. It's a C, correct. So Z intersection something should give me a Q. So I search for the Q here. It's give me an R. Z intersection something should give me a J. The J is here. It's give me a K. And Z intersection something should give me a B. The B is here. The something is a C. Okay, that will be the plain text. Okay, and we say that we have that. Do you think that there is a way to cut that so we can see a correct word? For example, do you think that there is a word in English that have W and before the W there is a C at the end? We can ask the dictionary, but I don't think there is a word like that, no? So look, I'm going to ask the dictionary. Is there a word that at the end have a CW? So look at the word that ends with CW. There is no word that ends with CW. So I arrive to a contradiction. So which means that two-letter word. So then that we find that it cannot be a two-letter word, we try a two-letter word. What about if now we know that we have a 3-letter word at the end. Okay? So I come from this, and we have a 3-letter word. So I'm going to ask my dictionary, show me the 3-letter word that have W, something, and R. There is only one, which is war. So if it's a 3-letter word, this one have to be war. Yes?
It's 410.
Sorry for that.
Oh, it's fine. I'll just let you know.
Okay, so we will arrive to a contradiction. You will try with a 4-letter word. You will arrive to another, no, the 4-letter word will be the correct one. And this is 6 is the answer. 6 is the answer. Yeah, the answer. And oh, sorry. Here it was. So if you use the word Joe as the password, you will see that this is 6 is the answer. Of course, it's much more difficult because you remove the space. So try to do it, and you will find that 6 is the answer, and there is no way to escape from that. You have to arrive to 6 is the answer. Okay, I stop here. I see you next week. Remember, please work on the first homework.